Hello, this is Mr. H. I'm going to go over each of these problems on the homework number 8 just to make sure we know how to do them. I'm going to use Desmos to do some of the graphing. Remember, you can always use that as a resource if you are graphing to make sure your answer is correct. All right, so the main focus of this assignment is that there is removable discontinuity, which happens when we have a factor in the numerator and denominator that cancels out. Again, that's called removable discontinuity. So the fact that both of these are the same factor, they cancel out the top and bottom, and the actual number that is going to have the discontinuity is where we set this equal to 0. So what value makes this equal to 0? That'd be -1. The reason for removable discontinuity is that if I plug in a +1 right here, I'll have 1 minus 1 in the denominator, and you cannot divide by 0 in mathematics. So that's why we have this gap or hole in the graph where this number occurs, is because we cannot divide by 0. Right? We can have an answer at like 0.99 or 1.001. So all the little fractions right next to +1 still exist, but when we get to right exactly at +1, there is an undefined answer there. So I'm going to go ahead and graph the equation we have left. We have to look at this and see this is a linear equation, right? This is an x to the 1, so this is a slope of 2 over 1 starting at +1. Start here, go up 2 over 1, and just repeat that a few times. That will be the line. Okay, right there, that looks good. And remember, we have a defined answer for all these x's except at x equals 1. So if I go to x equals 1, just right here on the x-axis, +1, right here really does not have an answer. So you put an open circle and erase the part on the inside. It should just be an open circle. So we got a line there with no answer at x equals 1. Let's look at that on Desmos real fast to see how that would show up. So if I bring this over here, I'm going to graph 2x plus 1, actually the whole graph. So I'm going to have f of x, right, equals fraction, and it's going to be x minus 1 and 2x plus 1. The bottom here we'll have x minus 1. Right, so it looks just like a regular old graph here, right? Just looks like a solid line, but if you zoom in and we look at +1 right here, the x-axis of +1, that moves us up here to +1. We'll see right when I get there, I gotta be exact. See how it's undefined? And you can see the open circle. So it doesn't appear there without me clicking on it. So if you're checking your answer, just know that the removable discontinuities do not show up. All right, so let's go ahead and look at number 2. There we go. So this time we have a factor of x plus 5 on the top and bottom. So I'm going to call it the removable discontinuity, RD for short, is where x plus 5 equals 0. So it's going to be at x equals -5. Right? And what I'm left with that I need to graph is 4 over x plus 2. So this is definitely a different type of graph than number 1. This is not a straight line. Right? And we have been working all week to put this in the format that's familiar. So this is what we came up with during this week, that we want to factor out a numerator if it is a number other than 1. so that we have a placeholder of 1 here, and the fact that the coefficient of x on the bottom is also 1. We do not have a number over here for our horizontal asymptote, so we're going to use 0. So from this, make that green. Now we're going to have a horizontal asymptote here. Oh, and the fact that it has a variable in the denominator lets me know it's a rational function. So it's good to know, in general, this is what we're graphing before we start, because of the variable in the denominator, as opposed to number 1, where the variables are just the numerator, so it's a straight line. And our horizontal or vertical asymptote will be at -2. So, and my a value here is 4, which means from the intersection of the asymptotes, I'm going to go up 4 and right 1, and down 4 and left 1. 2, 3, 4. Those are the reference points. There we go. And same thing here. And we have a removable discontinuity at x equals -5. So x-axis, -1, -2, -3, -4. Here's -5, which means right here should be an open circle. Let's go back down, see here, number 3. All right, so once again, we have an x minus 3 canceling out. So the removable discontinuity is at, see, x minus 3 equals 0 or x equals 3. And we're left to graph, this time, x squared minus 4, which is a quadratic equation, right? That's to the second power, so it's a quadratic. So we're going to start at -4, y-intercept, 1, 2, 3, 4. Let's see if I get that right. 1, 2, 3, 4. And it's quadratic with a value of 1, so we're going to go up 1, over 1, up 3 more, up 5 more. Remember, it goes 1, 3, 5, and we have an a value of 1 here. And of course, this negative side is the same. That looks something like this. Parabola shape. Not a V shape, but parabola shape. But with removable at 3. Right here, +3. So +3 is right here. Here, that would make this open circle. Hopefully getting the hang of it now when they're already factored. So after this, we might not have them already in factors. We'll have to factor it ourselves. Starting on number 4, you can see that the top here is not factored. So we have to look back to our algebra 1 and recall like that this is a difference of squares, meaning it's, I can rewrite it as x squared minus 5 squared, since 5 squared is 25. So from there, I know the factors will be x plus 5 and x minus 5. Now, if you're not sure why this is the case, then we need to work together a little bit after school to figure out why this is true. But now you can see we have the same factor on the top and bottom. So the removable discontinuity is going to be where this equals 0, so at -5 again. And we're left with, kind of like number 1, this is just a linear equation, right, with a slope of 1 over 1. So we're going to start at -5, 1, 2, 3, 4, 5, and just go up 1 and over 1. That just looks like that. So keep going, take this to the end here. Draw a straight line. And the removable discontinuity is at -5. So x, 1, 2, 3, 4, -5, which means right here at the very bottom should be open. Let's look at number 5. Again, we have to do some factoring. The bottom is strikingly similar to the top of number 4, right? Or number 5. Same as number 4, yeah. So once again, this is a difference of squares. See, subtraction is a difference, and 4 is the same as 2 squared, so I can write this as x plus 2 and x minus 2. And the top just has a GCF of 3. There's no square here, so we can't do what we did on the bottom. But just noticing that, well, there's a 3 here, a 6 here, so they have a 3 in common, go ahead and factor that out. So we have an x, because 3 times x is x, and then 3 times what is -6, and you'll get -2. And there's your removable discontinuity. At the RD of x equals 2. So 2 makes this equal to 0. We are left with 3 over x plus 2. 3 over 1 times x plus 2. Rational function, variables in the bottom. Horizontal asymptote, there's no number here, so we're going to use just a 0. And then the vertical will be at -2. And we have a value of 3, so I'm going to go up 3 over 1. That'll be one reference point. This will be the other, down 3, left 1. Okay, so there we go. I went too close. Should not touch the asymptote at all. So let's get close to it this time, but not actually touch it. Yeah. Asymptotes are the guidelines, but they never actually end up crossing each other. There we go. Okay, and lastly, discontinuities at +2. So we'll go to x equals 2, and there it is. Removable discontinuity. All right, let's finish up the front side here. There we go. All right, so very similar to number 5 on top, where we had a factor that was a number in common, right? There's a 3 on the top and bottom. This time we have a variable in common. See how they both have x's? Not just one x, but 2, right? This has 3 x's, this has 2, so they at least both have 2 x's, an x squared in common. So I factor that out. And we're left with x, because x squared times x is x to the third. X squared times what is 3x to the second? That would be +3. And that's going to be all over what's already down there in the bottom, an x plus 3. So there we have the removed discontinuity of -3. And we're left with, similar to number 3, quadratic, right? Just x squared. This time there's no -4 on there, so we're just going to start at 0, 0. Go up 1 over 1, up 3 more over 1, and then up 5 more and over 1. 1, 2, 3, 4, 5, there it is. Same thing on the other side. Another parabola, same shape, just moved up from the one we did earlier. And the removed discontinuity is at -3, so that would be over right here, that black. Yeah, there's the removed. Okay, let's take a look at the back side. And the only thing different on the back is that we have to do some trinomial factoring. Meaning there's 3 terms to factor, and they're quadratics. So that's where we have to do, some of you are familiar with this, we have to find out, well, what 2 numbers multiply And it's really these two numbers. What multiplies to negative 10, 1 times negative 10, and adds to 3. And we'll come up with 5 and 2 as the factors, with the 2 being negative, because 5 minus 2 is positive 3. So my two factors here will be x plus 5 and x minus 2. Bottom just stays the same. So we have an x minus 2 on the bottom. Cancels out, so the removable discontinuity here is at negative 5. Nope, that'd be wrong. Positive 2. There we go. Well, we're left with the graph x plus 5. There we go. Which is the same as 1 over 1. So I'm going to start at 5 and go up 1 over 1. 1, 2, 3, 4, 5, then up 1 over 1. There we go. And we have a discontinuity at 2 right here. So that'd make it right there. So just had to know this one part for the back side here, how to factor. So this time we have the bottom that's going to factor. The top will stay the same, can't do anything there. So we'll have what two numbers multiply to 1 times negative 6, negative 6, and add to negative 1. So we'll come up with probably what multiplies to 6 would be like 6 and 1, or 2 and 3. So 2 and 3, you can see that if I make the 3 negative, we'll have 2 minus 3 is negative 1, and then 2 times negative 3 is negative 6. So x plus 2 and x minus 3. There we go. So that will leave us with, since the top entirely canceled out, it's going to be 1 over x minus 3. So the removed discontinuity here is at negative 2. I just need to graph this right here. So horizontal asymptote's at 0. And then the vertical is at positive 3. See, we're at a value of 1, so it's just going to be up 1 over 1, down 1 over 1. Okay, it's really close there. Then we got one at the bottom, kind of longer. Ooh, there we go. And we'll go to negative 2 here. So negative 1, negative 2, right there. Let's go to number 9. So we have a binomial again. This is the same, I believe, numerator. Oh, very similar to number 5. So if we go back to number 5 real fast. So we had a 3x minus 6, so I factor out a 3. And this time we have a 2x minus 6. So they don't have a 3 in common, but they do have a 2 in common. All right, 2 goes into both. We have x minus 3. And then the denominator will be what multiplies to 12 and adds to negative 7. factors are 3 and 4, but they both need to be negative to add to negative 7, and they still multiply to positive 12. So x minus 3, which that will cancel, and x minus 4. So the removed discontinuity is 3. And I'm left to graph 2 over x minus 4, which is the same as just factoring that 2 out. So, and remember the horizontal, the horizontal asymptote is 0 here when there's no number present. So we have 0 here, and positive 4 here. 1, 2, 3, 4. And we have 2. There we go. Okay. And removable discontinuity is at positive 3. So we'll go to 1, 2, 3, right? So that reference point right there that we drew earlier is actually undefined. All right, do a little more factoring. Now you'll notice here that we actually have a number in front. So you'll notice on the other ones I was always multiplying these two together, but it was always 1 times this number. Well, now it's a 2. So if I'm doing this, got to be careful. Don't put a negative 3 here because it's actually negative 3 times 2. So that's negative 6. And then negative 5. Right, so that multiplies 2. Let's see here, probably 6 and 1. Right, so we have negative 6 over 1. And to get the factors, we can't so quickly just put the two factors in here as negative 6 and positive 1, because negative 6 times positive 1 equals negative 6. It doesn't equal negative 3. The last two parts here always multiply to be the last part here, but with negative 6 and 1 they don't, because we have this 2 in front once again. So what we do instead is do some grouping. Right, what these give us is a substitution of negative 5x. So instead of negative 5x, we're going to put, it's going to be negative 6 plus 1. So that's the same as negative 5, and then do a grouping. So quite a bit, a little bit more thinking here. If we have a value other than 1 here, you see there's a little bit more work involved to factor. But now once we do the grouping, you can see like it's more the same. So both of these have a 2 and an x as a factor. Factor that out. Left with x minus 3. And then these factors, the first and second, have to match. So this is also an x minus 3, which means that this must be a positive 1, because to keep it the same. So our two factors, after all that, are going to be 2x plus 1, right? That's 2x, and the plus 1, and then the x minus 3. And if you look carefully, yeah, 1 times negative 3 does equal negative 3. We have the 2x times x does equal the 2x squared. And then we have 2 times negative 3 is negative 6. And then 1 times x is 1. So the negative 6 plus 1 does equal the negative 5. Now there's a bunch of ways of getting this answer. This is just one method. So if you can come up with another method that works that gives you the same two factors, that's fine as well. So we have removable discontinuity at 3. And we're graphing 2x plus 1 or 2 over 1x plus 1. So start at 1, go up 2 over 1. And the removable is at 3. Go 1, 2, here's 3, so right there. All right, let's wrap up the last 2 here. So 11 and 12 have cubic functions on the bottom that we have to factor. Now, very similar to what we just did on the last problem, and that's probably why we went in that order, we had to do a factor by grouping. Notice how there's 4 terms here? Even though it's a squared, there's 4 terms and we did this factor by grouping. So I'm going to do the same thing with the 4 terms just with the cubic function and factor it that way. We could also do the rational root theorem and do synthetic division. That's another way of doing it. But if you look carefully at here, you can see that, well, these two have a common factor, right? Take out an x squared. Left with x and plus 1. And the second two have a common factor. They both have a negative 9. So we can take out a negative 9 from both of those. And remember, these need to match. So negative 9 times x is negative 9x, and negative 9 times 1 is negative 9. So they end up matching, which means my factors will be x plus 1, right? And then x squared and minus 9. Look at that. And then on the bottom here we have x plus 1. Again, there's many different ways of doing this. This is just one of them. You might also look at this and see that, well, x squared minus 9, isn't that x squared, x plus 3 and x minus 3? That's true as well. However, we don't absolutely need this information to graph it. Since there's not like an x plus 3 or x minus 3 on the bottom, we don't really need to factor it more because nothing will cancel out. So my removable discontinuity will be at negative 1. And I'm left to graph x squared minus 9, another parabola. So we'll have it down here at 9, go up 1, 1, 2, 3, and then up 5, 1, 2, 3, 4, 5. There we go. We could even go up 7 this time if we wanted to. 1, 2, 3, 4, 5, 6, 7. There we go. So here's the parabola. With the removal at negative 1. So that'd be right here. It's negative 1. X equals negative 1. Right there. Alright, lastly, same idea. Let's do this by grouping. You could do synthetic if you wanted to, but grouping is a little faster. Take out the x squared. They both have that. We'll be remaining with an x and 2. To make this multiply back to this, we need an x and a 2 on the inside. Of course, these must match. The second must match the first. In order for it to be equal, though, right, this is a negative x and a negative 2. It needs to be a negative 1. So my factors will be x plus 2, and then x squared minus 1. And much like the last one, we're left with a parabola. So we have the removable discontinuity at negative 2. And the graph left over is quadratic starting at negative 1. We'll start at negative 1, go up 1 over 1, and then up 3 more, 1, 2, 3 over 1, and up 5 more, 1, 2, 3, 4, 5. Just mirror it on the other side here. There's our quadratic equation, a parabola. And the removable is at negative 2. Here's -2, right there. Okay, so that's all 12. Remember, you want to be able to do each of these on your own, though, with no help. Don't just write them down. Of course, I know how to do them on your own. And then also look at the different ways. If you did a different way of getting these factors, or if you went all the way and got +1 and -1, that's okay, right? This will just tell you those are the zeros, right? You can see here -1 and +1, it crosses the x-axis. So it does give you some information, although it's not absolutely necessary to get the right answer on these ones. All right, so go ahead and redo any of them that you need to, and we'll see you next time.